We've already looked at this first vertical motion model. It says an object is dropped. Its height equals negative 16 times t squared, t representing our time, plus s. S is our initial height. The one we want to focus on today is when it's thrown. When it's throwing an object, or you're jumping, or you're doing something, you're putting some velocity behind it. So that formula is h equals negative 16t squared plus vt plus s. And here's what all these variables mean. Again, h is our height in feet. Negative 16 times t squared, t is our time in motion. S still is our initial height, but v is our initial velocity in feet per second. In these models, the coefficient of t squared is 1/2 the acceleration due to gravity. On the surface of the Earth, this acceleration is approximately 32 feet per second per second. So that's where this negative 16 is coming from. It's not just being made up. It's really based on this gravity. Okay, sorry about that. So it's half of this gravity of 32 feet. So we're going to focus on this vertical motion model right there, keeping in mind that our initial velocity is v and our initial height is s. So let's take a look at this example. You jump off a 15-foot diving board with an initial upward speed of 3 feet per second. How long will it take you to hit the water? So as we go to do this problem, we're going to use, since we're adding some velocity to it, we're jumping off something, we're going to use our model height equals negative 16 times t squared plus our velocity times our time plus our initial height. Now it's important to keep in mind that this velocity can be positive or negative. It's going to be positive if an object's moving up, negative if an object's moving down. So read the problem and see what makes sense. Now my first instinct is to say you're jumping off a diving board, that we're moving down, but it tells us we have an initial upward speed. So our upward velocity is 3 feet per second. That means this has to be positive because we're jumping up to start. Okay, so now let's fill in this information. Our height equals negative 16 times our time squared, plus we're having an upward speed velocity of 3 feet per second, and we're starting, our initial height is 15. Once we have that filled in, we can use our quadratic formula. Now I'm going to use an x here. Actually, I don't have to. I guess I could use t, because that's what we're talking about. How long will it take? How long is our time? But it's going to be a negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's plug in what we know. ax squared plus bx plus c. Negative 3 plus or minus the square root of 3 squared minus 4 times a negative 16 times c, which is 15, all divided by 2 times a negative 16. Okay, so let's simplify what's under our radical sign here. 3 squared is 9. 4 times a negative 16 times 15 is a negative 960. All divided by 2 times a negative 16 is a negative 32. Negative 3 plus or minus the square root, change of 969, all divided by a negative 32. So we're going to do this twice. We're going to do it once with the plus and once with the minus. Negative 3 plus the square root of 969, then divided by negative 32. We're going to get that's approximately equal to negative 0.88. And then if I do negative 3 minus the square root of 969 divided by negative 32, I'm going to get that's approximately equal, try that again, approximately equal to 1.07. Excuse me. Now, if it's asking how long will it take you to hit the water, this negative answer isn't going to make sense. We're not going to have a negative amount of seconds of hitting water. So how long will it take us to hit the water? Approximately 1.07 seconds. So our vertical motion model we can also use a quadratic equation to find solutions to that.